There you go. Okay. Okay. This is about solving system of linear equation using matrices. Okay, basically this chapter, this entire chapter is using matrices or using another thing is similar to the matrix I want to explain in a moment, not today, of course. And so basically, this is everything using matrices or using determinant as another topic. But basically, it's another approach to solve a linear system of equations. And it's obvious that the way that we are doing the linear system of equations is completely weak because elimination and substitution is good when you have two equations, and when you have three equations, look like long and complicated, right? However, so you have four equations, crazy. And so you have 5, 6 equations, it's impossible by hand. So the mathematician create new way for solving linear system of equations using matrix. The matrix opened the door to the new approach because I want to explain the different algorithm using the matrices. And this algorithm we can solve using computer. And I want to explain everything in detail using software. Okay, I want to explain, of course, by hand first. To understand the idea behind this in the easy example, I can put any crazy example in the test because you open the software is free again. It's similar to the Desmos, but actually it's not Desmos, it's GeoGebra. But don't worry for this, in your moment I explained it. The first thing you should do is understand what is a matrices. And matrices in plural, in singular is matrix. Like that. Do you see this movie? The name is Matrix, or no? Do you see the movie? You see or no? Do you lie or you don't lie? I don't lie, actually. I don't lie. Okay. Definition for the matrix. The matrix is a rectangular array of numbers. Normally, some book we use in square bracket. Another book, no, using parentheses. I prefer bracket. I don't know why. Suppose 2, 3, 4, 5, 6, 7, 8, 9. Okay, something like that. This is a major rectangular array of number, okay? And the most important parameter of the matrix is the dimension. Dimension is, look, this matrix contains 2 rows. Row 1 is this row. Row 2 is this row. And 1, 2, 3, 4 columns. Column 1, column 2, column 3, and column 4. Therefore, this matrix, the dimension is 2 by 4. And the first number indicates the number of rows, and the second number indicates the number of columns. Okay, this is super important to understand this because we are using frequently dimension, matching the dimension, doesn't match the dimension. You need to determine the dimension of the matrix. Okay. The second thing, everyone follow me? Clear? Super, right? Easy. The first thing is a little bit tour about matrix classification, how you find, for example, when the one linear system of equation, the matrix associated with this. Okay, I record a video, no? This is I record a video. Yes, I record. Somebody record, tell me always. Now, suppose one example to understand. Example 1. Suppose this 60 minus 2 minus x minus 2y, sorry, plus 3z equal 4. This is equation number 1. The equation number 2 is 2x plus y minus 4c equal 3, equation 2. And minus 3x plus 4y minus c equal minus 2, equation number 3. This is a classic example, 3 equations, 3 unknown, x, y, and z. And we can represent using matrix. There are many ways to represent this linear system of equations using matrix. I want to explain the fundamental two ways. For example, you open one bracket to enclose just the coefficients in front the variable. Okay, for example, this is 1, negative 2, positive 3. So basically, the thing I did was I create one column of the x here. Okay, the column of the is the column 1, no? Column 1 is the column 2, and this is the column 3. This is the column for the y, and this is the column for the z. The second is 2, 1, minus 4. And the last one is minus 3, 4, and negative 1. Be careful with the sign because I suppose everything is positive, but the coefficient is when there's negative z is because it's negative 1. No? Okay, this is the matrix I call capital A. Normally, the notation that we are using for the matrix is capital R. Don't ask me why, because I don't know. But normally, I suppose it's because it's a big object, no? Que represent the system. Entonces es capital. And the dimension for this matrix is obvious, is 3 by 3. 3 row, 1, 2, 3, 4, 3 column. 1, 2, 3 column. Okay? Another matrix associated with this is capital X. Capital X normally is the matrix, and this is formed by the variable. The variable is x, y, z. No? This is x, y, z. So this is capital that represent matrix, and this is just little x that represent the variable. This is x is this x, and this is the dimension of this matrix 3 by 1 because we have 3 rows, 1, 2, 3, and only 1 column. Entonces, when this situation happens, when the dimension, at least one dimension is 1, this matrix is called vector. It is very, very similar to the physics. I don't know if you took physics or not. Is dimension when at least one dimension. In this case, 3 by 1, but maybe another vector is 20 by 1. No? So when the one dimension is 1, is likewise. For example, I took this, okay, I call capital B, okay, is 4, 3, and negative 2. Okay, is the number in the right hand side, no? Yeah, again, it's a vector 3 by 1. Now, in your moment, I want to, well, let's do it now. Why not? We can, but maybe you don't understand very well. You can express it in matrix form, this system, this linear system of equation like that. Capital A matrix, que is this, multiplication by capital X vector, que is this, equal capital B. Now this is one matrix representation for this system. And I want to show you now how we can manipulate algebraically this. But you manipulate algebraically, no, like we are doing before, equation by equation. No. We are doing together, like one mathematical object. Okay, this is the fantastic advantage of the working with the matrix. And one advantage. There are several advantages for the manipulation with the matrix. Another advantage is that we can use in computer that you enter the matrix and the computer for you the system. And also another advantage is Do you remember when you have infinity many solution or no solution? It's very, very complicated. I don't remember very well, Professor. When you have infinity many solution, we have free variable. So I don't understand very well. Now you see clear, super clear when you use a matrix, the amount of free variable, how many free variable we have in our system. So everything is clear, everything is fast, everything is fantastic. Nobody, engineer and scientists, never using elimination or substitution. Hello, this is the kindergarten guys. However, in engineering, we have a problem that contains, for example, 25 equations and 25 unknown. We are doing by elimination. No, because you match equation 1 and equation 2, and you obtain another equation. I don't know how you call it. Because we have 4, 5, 6, 25 equations. It's crazy. Okay? However, you condense it in matrix form, you manipulate not by hand, because it's crazy, you manipulate by computer, software. There are several software to do this job, and you find the solution, right? This is one way. This is one way. Another way we study today is the augmented matrix. Augmented matrix. Okay, in this matrix, in this example, we have A, B, and X, no, like that. But in this augmented matrix, different. We are doing more easy, simplify, easy way. Is you copy A, so you copy one matrix, gets formed by A. The augmented matrix A and B together without X. So you copy A, get 1, negative 2, 3, 2, 1, negative 4, negative 3, 4, and negative 1. Okay, sorry here. And you separate by one line. Okay, by the way, the computer have no this line. In your paper, you put this line to separate the left-hand side and the right-hand side. On the right-hand side, you put 4, 3, and negative 2. And this is the augmented matrix describe perfectly the equation. The only thing you omit is the variable. But you know that this column corresponds with the X value, this column corresponds with the Y value, and this column corresponds with the Z value, and this column is the right-hand side numbers. By the way, what is the dimension of this matrix? Oh, it's 1, 2, 3, 3 row by 4, because we have 1, 2, 3, and 4 columns. Okay? And normally, the amount of row represent the equation. In our problem, we have 3 equations, no? So we expect 3 rows. The amount of column represent the unknown. In this case, we have 3 unknown, but 1 extra for the right-hand side. Super. Do you understand very well the idea for the matrix representation? Question. No? This is very, very straightforward. It's clear. Super clear. Okay. Let me complicate a little bit your life. A little bit, not too much. Let me put a weird example, and you help me to find the augmented matrix associated with the system. Okay, let me erase the board. Okay, suppose this system. Example 2, let me go. Example 2. So my question say, well, professor, write the augmented matrix associated with this system. You have X plus Y equal 20. And this is my equation 1. C plus Y equal 40. This is my equation 2. And the third is X plus 2Y plus 3Z equal 60. This is equation 3. Okay, so you have to write augmented matrix associated with this system, because After that, I get inside the computer, and the computer help me to solve it. Okay. Entonces es, how many equations we have? How many? How many? Come on, wake up. I need participation today. And what about Joyce? Joyce, you are there or no? Joyce, activate the microphone. Ah, Joyce is here, right? How many rows we have in my matrix? 3, because we have 3 equations. Very well. Okay, okay. Entonces I write the big bracket. I know that we have 3 rows, bam, 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 because we have 1, 2, 3 equations. Okay, okay, okay. Remember, super, extremely important. The organization. This is the column for the X. This is the column for the Y. This is the column for the Z. I separate with the line, vertical line, can separate left-hand side and right-hand side. Yeah, in the right-hand side, I put a number, right? Entonces es, supposing the first equation. How you translate equation number 1 to the matrix form? Well, the coefficients in front of the X is 1. The coefficients in front of the Y is 1. The coefficients in front of the Z, we have no Z, is missing. Is equal 6, equal 20, sorry, 20. And this row represents the first equation. And the second equation, I put it completely disorganized to confuse you. X is missing, no X. Y is 1, Z is 1, and the right-hand side is 4. And the last equation is 1, 2, 3, no? It's 3? See, 3. 3 and 6. End the story. This is the matrix representation, augmented matrix associated with this system. My question is, what's the dimension of this matrix, please? Dimension. Dimension. What is the dimension of our matrix? 3 by 4. Very well. Who is that? Christian Leiva. 3 by 4. 3 by 4. Christian Leiva say 3 by 4. 3 row, because of 3 equations, and 4 columns. Why 4 columns? The classical 3 columns of the variable x, y, z, and 1 extra for the augmented matrix, because you, well, you put, attach, no? The okay, the right-hand side, no? Okay, so you are ready at least to convert a system of equation, linear system of equation. Guy, non-linear is impossible using the matrix. No. This technique we studied in this chapter is only for the linear. And linear is extremely important in engineering and scientists and science. Okay, then linear is super important. So we use a matrix to do the easy way, the computation. Okay, so how you manipulate the matrix? Ooh. Okay, we manipulate the matrix. Let's explain by hand. Suppose we have in the jungle, we have no computer, we have no software. We need to understand where come from the thing. Actually, in the real life, no. In the real life, in the test, you using the software, but you, well, okay. In the test, I put a question in which you have to do by hand, but not entirely by hand, one piece of the algorithm. Because it's too long. And the rest you can use in, of course, computer. Okay, so we are, in order to manipulate the matrix, we are doing one thing, it's called elementary row operations. Now you perform operation in the row because it's similar to the thing that we are doing by elimination. You remember elimination, you, for example, you multiply one equation by a number and the equation stays the same. It's totally the same equation. It's the same line or the same plane or the same hyperplane in multiple dimensions. When you multiply one equation by one number, it's the same. So we have, we have 3 fundamental elementary row operations. The first one que is super easy to understand, is when you interchange to row. And this is perfect valid, this idea, because we have a system. So I call equation 1, equation 2, equation 3, equation 4, equation 25. But I want, for some reason, okay, you don't understand very well now, you interchange. Suppose I interchange number 1 and 25. I put 25 in the place 1, I put a 1 in the place 25. This is possible, do it, because the system is the same. In order to simplify, sometimes, not always, we apply this row or row operation, okay? It's interchange, for example, row 1 and row 2. And the symbolic way to understand this is using this symbol, interchange. Let's see one example that you can see more clear. Example to understand the row operation number 1. Suppose this matrix. 2, -5, 3, 2. 17. I want to perform in this direction this row operation. Row 1, interchange, row 2. Well. Entonces, I copy 3, 2, 17. Remember the bar que separate the right hand side and the left hand side. 2, -5, and 5. Maybe you ask, well, professor, but what is the application of this? You see in your moment, I promise. The thing you need to understand is the row operation. So this is possible to do it always. Interchange. Two equations, because basically it's the same system, but the only thing you should do is put in different order, huh? But it's the same system of equation. Number 2 is multiply. You multiply, for example, row. When you talk about row, is equation, it's the same, by non-zero number. Okay, suppose again the same example. It is 2, -5, the same. I copy the same. 5, 3, 2, 17. But I propose you different row operation. It's multiplication by 3. And you need to be familiar with this new notation I want to explain. That was the first. But the second is, suppose 3, row 1, arrow, row 1. What means that? If you multiply the entire row 1 by 3 and storage this new number in the row 1. So basically is 6, -15, and positive 15, no? Because the thing I want doing is multiplication the entire row 1 by 3. 3 times 2, 6. 3 times -5, -15. 3 times +5, +15. And the second row stay the same because I do not perform any operation using the row 2. That's it. And you know, it is no surprise for you. And when you multiply one equation, because I need to use in elimination, for example, you multiply 1 because I want elimination, +6, -6. You multiply one equation by 2, another equation by 3. The equation doesn't change. It's the same. So if you multiply by one number, one row, this matrix is equivalent to the original matrix. Doesn't affect. Okay, and the last row operation, in my opinion, is the most important, is add a multiple of one row to another row. Don't worry, I want to explain it. We continue doing the same example. 3, 2, 17, and 5. I want to perform this row operation. Look at that, look at that. 2R1 plus R2 storage in R2. Now the thing we're doing is you multiply by one arbitrary factor. You say, well, professor, where come from these two? Well, no. This is just example, no? In your moment, you understand very well where come from these two. Or not these two, this is the multiple. The multiple. The multiple means multiplication by one number, right? You multiply by 2, the entire row 1 is this, row 1. Addition, row 2. And this new number, you storage in row 2. Therefore, in my new matrix, the row 1 stay the same. Why stay the same? Because participate in the game, look here, row 1, but the information gets changing in row 2. Okay, entonces basically es 2 times 2 is 4, 4 plus 3 is 7. Do you understand where I come from the 7? Repetition, the first number, row 1 is 2. The factor is 2. 2. Let me use another color. 2 times 2 is 4. 4 plus 3 is 7. Yeah, I put a 7 here. Okay. The second is 2 times 5 is negative 10. Negative 10 plus 2 is negative 8. Do you understand where I come from negative 8? Repetition. 2 times negative 5 is negative 10. And negative 10 plus 2 is negative 8. The last one is 2 times 5 is 10. 10 plus 17, 27. Question. This is the most complicated row operation. The student normally don't understand very well, but we are using every day. 27. Any question? Any question? Come on. Clear? Row operation. So let me summarize. You have a system of equation. Immediately, you write like a matrix 4 and perform row operation inside. I don't explain the algorithm. You understand only row operation. Okay, basically, we have only 3 row operations. 1, 2, 3. It's interchange and lost the what? Do you hear me or no? What's going on? The connection is okay or no?
I'm back.
Okay. 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 Only one student say. Okay.
I'm back. Lost connection. I don't know what happened.
Okay. Okay. Let me try now. I don't know if you understand or you don't understand, because this is easy or relatively easy, but have a lot of detail. The thing is, the thing I try to explain so far is, we have a system, you convert a matrix 4, and doing row operation, you manipulate the matrix, the original matrix, in order to solve the system. Okay, entonces how? The idea que fly in the air is not clear. Bueno, professor, what is the algorithm to solving the system of equation using matrix? Okay, this is the crucial moment to explain the algorithm. Okay, basically, we have 2 algorithms. The first one is called Gauss elimination. Gauss elimination. And the second, Gauss is the last name of the famous German mathematician. This is the most important mathematician in the history of the mathematics, Gauss. And the second is Gauss also, but Gauss Jordan. Elimination. I suppose that Jordan apport new idea inside the Gauss. And what is the idea? What is the idea? What is the idea? Suppose that we have the original matrix. I don't care the number. This is not important. Suppose here. The algorithm is, look, this is important moment, crucial moment now, please pay attention. Okay, I'm putting off the air conditioner. You hear very well without noise. You create somehow using your imagination. There are several ways. You see clear in the example. Okay, the first number here, the first one. The normal is called first. First pivot. First pivot should be 1. This is easy or relatively easy. Suppose que it's not 1, is 10. Well, you divide by 10 the entire row 1, divide by 10, and you convert to 1. This is one possibility. Another possibility is, suppose que, if, for example, the equation 3 have 1 here, and you interchange. But it's important, not strictly mandatory, but it's important to create one pivot que es 1. Okay? And because this pivot allows us doing row operation, get this number and this number, I transform it. So I working basically in the column 1 to be 0, 0, 0. Suppose get one big system que contain 25 equations. Entonces, this is the first pivot and the first equation, and below the pivot, everything is 0, 0, 0. Okay, I finish. I finish the column 1. I move on the column 2. And the column 2, I don't touch the first one. No. I touch the second. And this would be the second pivot. Entonces I create somehow get 1 here. I don't care that number. For a moment, I don't care. I'm doing row operations. You see in the example, I promise. The thing is that you understand the general idea for the algorithm. You create 0 here. Bam, bam, boom, 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 boom. I don't care that we have 100 equations, 25 equations. Entonces we continue in the same strategy. And the next column, I don't care this number, I don't care this number. I go to create a third pivot. And below the pivot, 0, 0, 0. Yeah, I continue. Suppose the number 4 is, I don't care, 4 pivot, 0, 0, 0. Of course, when you transform it, this number change. This number no stay the same. It's another number. It's another number. It's not the original number. It's another number because we are doing transformation. No? Now, when you finish, okay, I forgot. Sorry, I forgot something. Okay, I forgot. Okay, this process. Continue. But in the last one, this is continuation. Boom. But this is number. I suppose that this is number. But in the last, we have a pivot 1. Suppose that this is the pivot 25th. Because the system contains 25 equations. Okay. Entonces, this is the line que separate left-hand side and right-hand side. It's another number. Okay. We finished? Yes. We almost finished. Because this is similar, very, very similar to the problem that we are doing in the test number 2, in which you apply back substitution. Because suppose that the name of this variable is X, Y, C, W, blah, 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 blah. I don't know. Suppose this is X1. Suppose. So this is X1. So the last row is 0X, 0Y, 0C, 0W. The only guy que stay alive is X1. X1 is equal this number. I copy that. The next equation, I suppose que is 0, 0, 0, 0, but we have one pivot here, I suppose. Look, in this diagonal, we have the collection of the pivot. And this is, suppose this is Y1. Y1 plus X1 equal another number. There's a number here. Okay, therefore, see, I know X1 substitution here and computed Y1, and so on. It's a typical back substitution. Okay? Okay, this is the ghost. Ghost discovered this idea. Entonces, pero Jordan aported in the algorithm new idea. Okay. Entonces now, Jordan proposed, well, why no? See, you are doing in this direction, look, 0, 0, 0. Pivot here, 0, 0. Pivot here, 0. Pivot here, 0. Pivot here, 0. And 1 here, right? Why no? Doing not only below the pivots, below and above the pivot. Doing row operation, I create 0 here, 0 here, 0 here, 0 here. Sorry, well, 0 here, here, 0, 0, 0, 0, 0, 0, 0, 0, 0. And this number is, I don't know, arbitrary number. Arbitrary, no. The number that we can do that when the row operation is performed. Entonces, the magic for the Jordan was, this is X column, Y column, C column, W column, Y1 column, X1 column. It's a step name of the verb. I don't know. You discover, okay, let me try to translate this row to equation. This row is 1x, look, 1x, no y, no c, no w, no y1, no, okay, because it's missing, it's equal number. The second is, I'm using green color. Is no x, 1y equal this number. And we have no C, no W, no Y1, no Y2. So automatically, when you transform it using Gauss-Jordan elimination, you have one diagonal matrix in which you have only the pivot 1, 1, 1, 1, 1, 1. The rest is 0, big 0, big 0. And the first one is equal the first number on the right-hand side. The second is the second number on the right-hand side. And we're solving super, super easy. Okay, this problem. I don't know if you are clear or no. You have a question. Immediately, we are doing one example now to see the procedure, no? Okay, by the way, it's long. It's long. Okay, basic is the basic idea. Okay, you have a system completely crazy, completely disorganized. I have no idea how you organize that way. You put it inside the matrix, one column for the X, one column for the Y, one column for the Z, one column for the another variable. Okay, you call it any name, any letter. Now, you start the process for the Gauss or Gauss-Jordan, no? You create the pivot should be 1. Another book, not necessarily 1, but I like 1 because it's easy to understand. And using row operation, you create below and above the pivot 0. When you finish the process, you solve the system because the matrix is diagonal matrix, only 1, 1, 1, 1, 1, 1, 1, 1 in the main diagonal. In the rest, in the right-hand side, we have the solution of the system. Okay? Let's move on to the example. And you see clear now. And you help me to understand the row operation, because sometimes it's a little bit complicated. That is the reason. That is the reason. Que we solving always or almost always by calculator, no? By computer. Okay. Well, basically the graphic calculator like a TI 83 plus Texas Instrument. Or TI 89, again, same manufacturer, have possibility to perform Gauss Jordan or Jordan. Gauss elimination or Gauss Jordan elimination, both. But this is too expensive. This is $150, right? No good, no good. I don't like. However, in the new day, we have internet, we have computer, we have software in the cloud, like a GeoGebra Classic. I want to teach you how we're using this. I don't know si today, maybe tomorrow. Tomorrow, no, next day. Okay, but basically, my recommendation is create account in GeoGebra, no? It's similar to Desmos, no? Pero GeoGebra Classic. Be careful because there are several options. You go to the www GeoGebra Classic. Click here. No, not today. I want to show you next. So I want to illustrate one example like that. Suppose this example. 3, 7, negative 15, negative 12. 1, 2, negative 4, negative 3, negative 4, negative 6, 15, and 16. Okay, where come from this? Well, I suppose that we have a system of equation, no? I suppose that we have a system of equation. Okay, the first equation is 3x plus 7y minus 15z equal right hand side get 2. We have another equation that is 1x plus 2y minus 4z equal negative 3. And the last equation is negative 4x minus 6y plus 15z equals 16. And immediately, I give you in the test the system in the traditional way. Because the first job is convert to the matrix, no? Okay. Now you try to apply the Gauss-Jordan or Gauss elimination method. We are using both because Gauss elimination stop in one moment because you are doing the element below the pivot 0. For Gauss-Jordan, no. Gauss-Jordan create below and above. So we are doing below first, stop, we solve the system like a Gauss elimination, and we continue with the Jordan part. Okay. Entonces, now remember in the method we apply 3 classical row operations: interchange to row, multiplication 1 row by a number, I don't care what number, or multiplication by one number plus another row and storage in another row. Then my first goal is create the first pivot que es here. Pero it's 3, wow, no good. So you can divide by 3. 3 divided by 3 is 1, 7 divided by 3, oh, it's a fraction. I don't like fraction. Much better, in my opinion, is interchange the row 2 and row 1. So interchange row 1 and row 2 in order to create the pivot 1 like a 1. So I copy 1, 2, negative 4, 3, 7, negative 15, sorry, this is negative 3, this is 15, this is negative 12, this is negative 4, stay the same, 15 and 16. So the only thing I did was interchange the row 1 and row 2 and the original matrix because I need this one here that's important for me because this represents the first pivot. Okay? So always we start doing something. And suppose you say, well, professor, in another example that we have no any equation that start in 1. Well, okay. Divided by 3 or divided by whatever you want, but you need to create one here in the first. Okay? After that, what should I do? Well, I need to create 0 and 0 here, below the first pivot. Entonces I propose you this idea. Look, I copy 1, 2, -4, -3, exactly the same because I use it, but don't touch. Entonces I propose the following row operation. Look. This is the most important moment now. Please pay attention, coño. This is -3. Why -3? Because there's the same number, but the opposite sign. -3 multiplication by row 1 plus row 2 and storage in row 2. Now the only row can change in this operation is row 2. So this number is different, but this number stays the same. -4, -6, 15, and 16. Let's do it. You multiply 1, this one, times -3 is -3. -3 plus 3 is 0. Do you see where I go from this 0? Okay. 1 times the factor, in our example, -3. I put intention on -3 plus row 2 is 3, storage and row 2. Okay. This is my intention, 0 here. But this no. This is 2 times -3 is -6. And -6 plus 7 is 1. Do you understand where I go from this one? Repetition. 2 times -3 is -6. It's a factor. Plus row 2 in the second position is 7. And -6 plus 7 is 1. It's a coincidence. Now, the third one, -4 times -3 is -12. And -12, no, +12. Okay, -4 and -3 is +12. And +12 minus 15 is -3. And next is 3, -3 times -3 is +9. And +9 minus 12 is negative. Do you see? Confusing? Repetition? Come on. Guy? Good? Okay. Repetition. Repeat again. Okay. I understand. The first time you see that it's not clear. It's a little bit complicated to understand. Let me try to create my best skill to explain something. Look. Okay. Remember, -3 was the factor in this row operation. And you multiply 4 times. -3, -3, -3. And you multiply by 1. 1 is this guy. Plus row 2. Well, row 2, remember we have nothing here in blank. Row 2 is this, 3. It's obvious that this is 0. I'm storage 0 here. -3 again, the same, it's common factor. I select to create 0 here. Is 2 times 2 is -6 plus in row 2 is 7. So it's -6 plus 1. This one is this one. The second is -4. This guy. Negative 4 times negative 3 is positive 12. Plus minus 15. Okay, this is positive 12, this is minus 15 and negative 3. This is negative 3, this is negative 3. And the last one is negative 3 times negative 3. That this negative 3 is this. Plus something. And the row 2 is negative 12. Negative 12. Entonces this is 9. And 9 plus the 9. And es minus 3. Es a coincidence. Pero es a coincidence. Okay, this is negative 3. Okay? Super o no? Complicated or no? Okay, who there? Who there? Because this is the part of the game, of the algorithm. Create this formula, this equation for the next transformation. Okay, what's my goal? My goal is create 0 in this, in the next, in the column 1. We're working in the column 1. I create 1 here in the first pivot. I create 0 and below, and now 0. And well, we have no more, no? See, we have more 0, 0, 0, 0, 0, but stop here. So what is the formula? In your opinion, what is the formula? The formula is, let me explain. I want to explain. You only pay attention. Look, is your multiplication, the factor 4, but positive 4. Why positive 4? Because there's the same number of these and opposite sign is negative positive. Multiplied by row 1. Why row 1? Because row 1 is the row that is located the first pivot. Okay, we manipulate using this pivot. Pivot is the guy that have the control of this column. Now you multiply in the row in which we have a pivot 1, right? Plus the row 3 is in which I want to eliminate this. After this transformation, I suppose we expect that we get 0 here. And the number below the pivot. Okay, let's try. Do you understand where I come from this formula, or it's confusing? Confusing, clear, confusing, clear, confusing, clear. Come on, opinion, opinion. Come on, guy. Good. Okay, Giovanni says good. Joy, I want to hear your opinion, Joyce. Good. Joy says sum up. I understand. Okay. Okay. This is no big deal, but it's weird. It's a new thing. Maybe you don't see never in your life that part. Okay. So let me use again the black color. Okay. I copy exactly the same the row 1 because I using in the formula, but I don't store the information in row 3. The only row that change is row 3. Row 2, no. Row 2 stay the same. I never include in the formula. Now it stays the same. Now let's do it. It's 1 times 4 is 4. 4 minus 4 is 0. Ooh, exactly we need. Repetition, guys. 4 multiplication by 1, que es the pivot, plus minus 4. Who is this minus 4? This is minus 4. It's 0. Okay, likewise, 4, because it's the same factor. Multiplication by 2. These 2. Plus negative 6, ¿no? Entonces es, let me see, es 8 minus es 2. Okay. Now 4 multiplication by negative 4. Plus row 3 is 15, no? 15. This is a negative 16, and this is a positive 15 and negative 1. Negative 1, very, very well. And 4 multiplication by negative 3 is this guy. It's negative 12 plus 16, no? Okay, row 3, the last guy is 16. This is 4, no? Positive 4. Okay, I finished the column 1. The column 1 is done. I know que it's easy, but it's too long. That is the reason in the test, listen to me, I ask you 1, 2, or 3 row operation, no more. And the rest that we are doing in the test, we are using computer. In one moment, not today, I suppose. I want to teach you how we're using this. It's super easy. Super easy. Okay. Let's continue. But remember, we have infinity board, and we continue here. What is the next step? Well, I finished the column 1. I need to go to the column 2. In the column 2, I have the pivot. Look at that. It's a coincidence. No, it's not coincidence. I create this example for this special to make easy. Suppose que es no 1, entonces you need to do something to be 1. But in this case, no, it's 1. Nice. I love it. Then, don't do anything in the pivot. Entonces I need to do below the pivot. No above, this is Jordan. Below que goes, below the pivot 0. Okay, entonces my question is, what is the formula to create 0 here? To create 0 here, using this 1 like a pivot. I finish this pivot. This pivot, I don't use it anymore. I'm using the second pivot. This is my second pivot. This is my second pivot. Look, this is my second pivot. And the second pivot helped me to create 0 in the column 2. And the third pivot is this 0 in the column 3. Okay? Entonces my question is, what is the formula? Who dare to propose me one formula? The formula to create 0 here. Bueno, I suppose que es the same number, no 2. No? With the opposite side. Multiplication by something. Multiplication by something is the row que contain the pivot and the column que es row 2 plus row 3. Store in row 3. This is the formula for the next row operation. Do you see or no? It's confusing? Because in the test, I don't give you the formula. You need to create using your imagination and create the formula. Yes? Okay. So I copy. Wait a second. I copy. Okay, I copy the row 1 exactly the same, because in this moment I'm done using. Wow. Okay, entonces -3. I copy the row 2 exactly the same because I'm using, but I don't touch. Well, I use it, but I don't override. Okay, 1, -3, and -3. Okay, so basically is 0, row 2, 0 times -2 plus row 3, que row 3 is 0, no? It's 0. Look at that. 0. It's 0. It's obvio que es 0. I like that because the 0 I create in the last step doesn't change. I want 0 here. Let me see if it's possible or not, according to this formula. Okay, look. It's 1, so -2 times 1 plus 2. Where come from these two? These two. It's 0. Wow, amazing. I like that. And -2 again times -3 is this guy. Plus -1. This is 5. Because this is 6 minus 1 and 5. 5. And now the last one is -2 times -3 again, because it's a coincidence. Es negative 3. Okay. Plus 4. Este, because it's 6 plus 4 is 10. This is 10. Okay, so I finish. Yes, I suppose que yes. Well, almost. If you want one sophisticated detail is, if you want to create the last pivot 1 here, you divide the entire equation 3, or row 3, you divide it by 5. Row 3 divided by 5, store in the new row 5, row 3. Okay, let's do it. Entonces, 1, 2, negative 4, negative 3. Don't forget this bar. 0, 1, minus 3, 0, 0, 1, and 2. Yes or no? Because divided by 5, divided by 5, divided by 5, divided by 5. 0 divided by 5 is 0. 5 divided by 5 is 1. Therefore, remember, this is x, this is y, this is z, this is right-hand side number. It's obvious, looking only the last equation. The last equation do not contain x, 0x, 0y, 1z equal to. I write like that to prove that, but in real life, you don't need to do anything. You are doing it that way. Look. Okay, you see, wow. Uy. Too much on that. This is x, this is y, this is z. Entonces es obvio que z es 2. And we're doing back substitution. Back substitution is y minus 3z equal minus 3. So this equation contains y, contains z, no contains x. But I know that c is 2, entonces y minus 6 is equal minus 3. Y is equal minus 3 plus 6 is 3. I'm taking the last equation, que es x plus 2y minus 4c equal minus 3. X, I don't know. 2 times y, que y is 3. Y is 3. Minus 4 times c, que c is 2. Equal minus 3. Entonces x plus 6 minus 8 equal minus 3. This is minus 2. 6 minus 8 is 2. Equal minus 3. And x is equal negative 1, no? Because it's minus 3 plus 2. X is equal minus 1. And the solution in this problem is the triple order negative 1, 3 que es y, 2 que es z. Entonces we finish the Gauss elimination procedure algorithm. We have only 10 minutes, carajo. Let me try to do fast. It's impossible to do it fast, but
Professor, we have 10 minutes. Is it possible for you to show us on the other thing? I'm gonna have to go back and review this a little bit more. But yeah, I just wanted to, you said the deal something.
A ver, what is your question, mister?
Never
I don't hear very well.
Never mind.
Okay. I want to illustrate. Okay, let's do it fast because we have only 10 minutes. Okay, so in this 10 minutes, I want to illustrate the continuation for this. Suppose that I'm doing now the following row operation. Okay, is, let me see, we are doing here. Now here, it's 4. Okay, 4, row 3, plus row 1, store on row 1. What's my objective? Row 1. What is my objective? Create 0 here. So I copy in my paper. 1, 2, 0. So I do something in order to modification row 1. No? You multiply by 4, get the opposite sign of negative 4 is positive 4. Okay, the 0 here, and this is 5. And the rest stays the same. 0, 1, minus 3, minus 3, 0, 0, 1, 2, no? Okay, now I continue. Yes, so I continue. I need to create, for example, 0 here, above that pivot. So I did that, I did that. The next row operation in my paper is 3 times row 3 plus row 2 store and row 2 because I want to modification row 2. So the answer for this is 1, 2, 0, 5. Stay the same. Row 1. Do you know that this method there are a lot of repetition? Now you transform a row 2. Get 0, 1, 0, 3. 0, 0, 1. Okay, almost, and 2 here, sorry. Almost. What the only thing you should do? Well, the only thing you should do is this 0. So the row operation, the last row operation is minus 2, row 1, because we're using that pivot, row 2, sorry, because we're using that pivot, row 2, pivot 2, plus row 1, stores, and row 1. And the answer is 1, 0, 0, 0, 1, 0, 0, 0, 1. In the right hand side, we have minus 1, 3, and 2. Wow, amazing. Look at that. Okay, interpretation, this answer. Look at that, look at that. Here, we have just one matrix. It's diagonal matrix. Diagonal matrix identity. This is identity. We study in detail in your moment. More clear this identity. Normally it's called I3 because dimension is 3 by 3. Dimension of this matrix I enclosed in the blue color, guys. 1, 1, 1, 1 in the main diagonal. In the right hand side number we have -1, 3, and 2. So that means x is equal -1, y equal +3, and c is equal to. Do you say, well, professor, what is the reason I need to do that? No, you don't need to do that. The problem is that when you're working with the software asks you, what do you want? Gauss elimination or Gauss Jordan? So you apply because the computer doing the computation. So I put Gauss Jordan. Automatically you get in the left hand side the identity matrix can only have 1 and 0, and the right hand side we have solution. X is equal to something, Y is equal to something, Z is equal to something. End the story. Okay? Okay? Little bit confusing? Confusing, very confusing. Remember, guys, this is pre-calculus, no? Class, this is not kindergarten class. Do you want to see a little bit? Do you want to see a little bit the software? And the rest of the time, in 5 minutes, the software. Don't do anything. Only watch me. This video, I will post it in Blackboard in YouTube today. And you can watch it again, and you try to do in your computer, no, in your GeoGebra. And I suppose next class everyone be ready to do that. Okay, let me try to find GeoGebra. Okay, share screen. Screen here. Okay, switching to, there you go, GeoGebra. Do you see that, GeoGebra?
Yes, sir, we do.
So you typing, you open your browser, and you type it www.geogebra.org /classic. Oh no, sorry, you typing GeoGebra Classic, and go to the browser, and you can see specifically click, double click on this, and you, of course, create account, guys. And you save your account here. So let's solve the same system that we are doing by hand. It's too much, too long. Let's use it in 5 seconds. No, 5 seconds, no, but 5 minutes at the time that we have available. Okay, so you open, look, you open here, and you click here, and the three horizontal line, you open here, and you select view. Where's view? View here, view. Because your GeoGebra is super complicated software, and they have different view. So you select only 3 views: algebra, CAS, and spreadsheet. Okay? Algebra, CAS, and spreadsheet. Boom. This is algebra. The left part is algebra. CAS is the middle part, and spreadsheet is obvious. It looks like similar to the spreadsheet Excel, no? Is this. And you type in the number 3, 7, the number and the matrix we're solving now, no? And you want to verification with the software. 15, -12, 1, 2, -4, -3, -4. Be careful with the number, because you change one number, only one number, you are doing different problem. If you change not only one number, if you change one sign, a different problem. And everyone make a mistake. -6, 15, and 16. No? So this is my matrix. Yes or no? Let me verification if we type in correct or incorrect. Okay. Okay. Everything is okay? Clear? And you select the number. Look, using the mouse, you select. And you right click, press right click, and create. Click create. Create what? Create matrix. Boom. Automatically, you can see in the algebra part the matrix associated with it. And your GeoGebra don't using bracket, using parentheses, but it's okay. I understand. And assign one arbitrary number. Matrix 1, M1. Okay. If you want to change the name, you right click and change the name, and you put Maria matrix, or Jose matrix, or A matrix, or B matrix, or C matrix, either one. No, but it's not important. And CAS is the most important. CAS is the fantastic way to solve the matrix. In CAS, you typing now. Look, you type in one function, and the name is reduced, capital letter, reduced. Oh, look at that. Reduced is the name. Reduced row echelon form. This is the technical name that normally is using in the last matrix after the Gauss-Jordan elimination. And you click here. Boom. And you put the matrix you want to perform this, because the matrix I call N1. This matrix I suppose we know. Press enter, bang. And this is the answer, guys. Boom, 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 bang. We got it. The answer is, in the left-hand side, we have the famous identity matrix in which we have in the main diagonal 1, 1, 1, 1, 1, 1, 1. And in the right-hand side, we have -1, +3, and +2. Therefore, the solution is x equal -1, y equal +3, and z equal +2. End the story. We practice. This is not too easy. We practice. Next time, we practice more example, more complicated and weird and tricky example. And you need to interpretation the answer in the computer. The computer is fantastic, but you are more fantastic than the computer, because you need to interpretation. In this case, I try to select the elementary example, is unique solution, but suppose we have infinity many solutions. or we have no solution. How you interpret that? I don't have idea, right? Okay. Any question? Remember, today I need, today no, tomorrow. Tomorrow, I wake up early in the morning, 8 o'clock, and start grading your test. Okay? Your test and submit, don't forget to submit the test online, right? Y I posted both grade and Blackboard. Any question? No problema. Okay. Thank you so
No,
much.
thank you. Have a
Okay.
nice day.
You too.
Thank you, Professor. Have a great day, sir.
Pleasure as always. Take care.